Good morning all. My 8-bit computer, Breadboard Computer, is driving the LCD and it's saying not quite hello world because I couldn't quite bring myself to write a program that long, but it's saying hello and then clearing the display and writing it again. It's going through a program loop. And that's the first time this has done anything that looks remotely like a computer. So I'm pretty happy. So let's take this right back to the beginning and I'll show you how this all came about. Good morning all. Today I want to put something on my 8-bit breadboard computer, and it is the LCD. Now that's currently on this breadboard where I just manually put commands in and sent them to the display. What I want to do now is try and write a message on this display. Maybe one that cycles round so that you can see it's doing something, and program all the sequence steps into the RAMs on my one instruction computer. Now really the issue here is one of timing. I don't really want to put all the data lines of this behind a latch and then all the control lines behind another latch, and then by using various patterns on the latches, set data, set control lines. What I want to do here is I want to put the data lines straight on my data bus, which is these 8 blue wires here. At the moment, the data bus can only read one readable device and write to one writable device, but I can extend that on so that it sits on the 8 data lines of this, which is where this switch is. The enable line on here, I've determined, according to this, that I need to invert one of my address decoder outputs because enable needs to be a positive going pulse. And what this effectively produces is a negative going pulse, the rising edge of which is what triggers the latches on here. And the reason for that is that they need to trigger at the halfway point where data is stable in the rest of the system. So here's my 555 clock. The rising edge of that triggers the 273, this one, which latches new RAM data onto the 2 parts of the computer. So it's stable during this period, which means that to latch from a readable device to a writable device, it has to happen halfway through that period, and that's that rising edge. But the LCD requires, and I believe it's the falling edge that actually latches the data bus data into the display. So I'm going to use a transistor to invert that signal. So first things first, the display is going to go here. I think these 2 wires are in the way. I want to move them, which I think means these 2 tantalum capacitors are in the way. So I'm going to move them here so I can fit all my grey wires, which I'm going to solder in here actually because I think they're quite a good way of getting this top connector down to the bottom. If only that connector had been at the bottom, it would have been so much easier. And then place it here and then route the data lines. And I think these all have to cross over because these data lines, I seem to remember, were all back to front. So let's get these 2 wires, which are my bus linking wires. Of course, I've got my new bus bridging PCBs and this sort of high-rise power distribution thing. And a couple of people said, when I had this plugged in like that, they said, why don't you run this straight into these 2 points on that connector? And I think that's a good idea, so I think I probably will do that. But let's just get these moved. I think I'll move them down to here for the moment. Another day of not wonderful lighting. So I balance this here. I'm just going to solder all of those so that the display and its connectors are as one. Right, iron is up to temperature. Bit of a clean up on the sponge. And then let's run across all of these, including the cathode and anode. These are gold plated, so they're taking a little bit of solder to take. 8 data lines. Can't see very well what I'm doing here. Right, that's done, so I can pull that out of its blue tack. and lift that out of my breadboard, and now that can sit in this breadboard like so, and then I just need to wire up the backlight, VDD is it, and VSS, ground, the contrast pin, the control pins and the data pins. So that's plugged in there, and now I can wire my VSS and VDD to plus and minus. Also the LED backlight, because I believe there was a resistor on the back of this board, so no resistor required. Let's get those done first. Oh, that's interesting. The display is tucked behind this connector here, which is holding it at a nice angle. And also you can see that these PCBs that I put to link the breadboards together, I've also used them vertically on the ends here, and the display is just sitting neatly behind that one. That's quite good, that. Right, I've got my 8 data lines there. I totally messed up the sizes. I just couldn't do the maths in my head, because the left here goes to the far right here and the far right here goes to the far left here. It wasn't easy. Contrast pot, that is the register select line. Read write is tied low. I've got my transistor here on right number 2, and I've got a 1K pull up there because of course this transistor only pulls down. So let's see if that works. I must admit, I've only got the odds at about 50-50 at the moment. Not feeling terribly hopeful, but let's switch on. And that's okay. That's just a reflection in the display of these LEDs. I'll have to sort that out. But the next thing is to write a couple of instructions into the memory, which puts this into mode with a blinking cursor so that we can see something. So I'm just going to work out what those are. So the first thing I want to do is put 0 in this latch, because the 0 bit here is being used for register select, and that needs to be a 0, and for some reason this has got FF in it. So I think I need 0, 0, 0, 0, and that writes a nibble, a 0 nibble, to the constant generator, the literal generator, and that writes the other nibble. So that should be relatively straightforward, because this is currently doing a 2-step program. So if I set this to 0, 0, I should be able to write that in and write it in again. That should be writing to device 0 zeros. Doesn't seem to be though, does it? Of course, it then needs to write from device 0, where the 0, 0 has been assembled, and put it into latch 1. This is latch 1, so I need to write from device 0 to device 1. That means I need a 3-step program, which means I've got to put a proper 3-sequence go-to in there. So let's do that. Okay, 0 goes to 1, 1 goes to 2, 2 goes back to 0. Yes, that's great. So that's 3 steps. And the steps need to be 0, 0. Let's go to the first step. Where's the first step? This is the actual address, and this is the next address. So actual address 0, I want 0, 0. Actual address 1, I want 0, 0. Actual address 2, I want 0, 1. So let's put a 1 in there, enter it in. Good. So that's got my constant of 0, 0 into here. That means that the lowest bit is now a 0, and that's on the RS line. It's a start. So now I want to put 0F and 38 onto the display, and that's done by going 0 to 0, F to 0, 3. Oh no, then I need to transfer that into there. So that's what is it? It's where have I put it? Oh, I put it on device 0. Yeah, so 0 to device 2. The LCD is device 2. Then 38. So 3, 0, 8, 0, 0, 2. That should do it. How many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's build a 9-step sequence and enter this data. So I'm just putting the go-tos in at the moment. I've done 4. 4 goes to 5. Step it on. 5 goes to 1106. Step it on. 6 goes to 1117. Step it on. 7 goes to 8, which is 1000. And 8 goes to 9. Oh no, I don't need that. Well, it doesn't really matter, does it? 8 goes to 9. Program that in, and then I can do 9 goes to 9, so it just locks up at that point. That should work, I think. If I step that on, why isn't that stepping on? Oh, because it's locked, of course. Yeah, I have to reset it to 0 with that. So 0 goes to 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it locks at 9. That'll do. Well, I didn't have the camera running, which was a shame, but yeah, going through that program, the one written on here, and I'll put some notes on there in a moment to explain what it does, has actually switched on the blinking cursor with underline on the display. So those commands have obviously got into there. That's kind of encouraging. So what does this program mean? Well, this means 0, 0 to device 1. You have to write literals as nibbles. You put out the first nibble to device 0, so you put out the 0 to device 0, then the second nibble to device 0, and it is little endian, I think. You put out the low nibble first. So this simply means that 0, 0 went to device 1, and that's those 3. This means that 0f went to device 2, which is the LCD, and that's those 3, and this one means that 38 goes to device 2, so 38 or 38 hex it is actually to device 2. So all I'm doing is saying 0, 0 into that register because I want the RS line to be low because I'm sending commands. When I send data, I actually want that least significant bit, so this would say 01. I want that to be high because I'm sending character data. But for the commands, which are 0f and 38, I can't explain what those are. I probably did in the previous video. I need to send those as commands to device 2 being the LCD. So far, so good. So the next part of the program, to write some legible characters onto here, means putting a 0, 1, so 0 to 0, 1 to 0, 0 to 1. That puts 0, 1 into device 1, so that will then say 0, 1. That takes the RS line high. Then we'll need to put a couple of characters on. Well, let's have AB, for example. So we want, say, 41, 4, 1, so 4 to 0, 1 to 0, 0 to 2, and then say B, so 42, both go to 0, and then 0 goes to 2. That should do it. It's now an 18-step sequence, which is painful. Right, I've programmed in this second section. I had to start writing the addresses in because I couldn't do it in my head. I've reset this. No, I haven't reset this. I'm going to reset this back to 0, which is this first instruction. And now I'm just going to step through the instructions, see if it works. So the first batch, simply write 0, 0 to there to put register select low on here. The next few instructions are 0 FO 02 and 30 80 02. That makes that have a flashing cursor, which it doesn't. It's cleared it actually, but it doesn't have a flashing cursor. Oh, maybe it does. I can see something. I don't know, that's really weird. Okay, let's carry on. 001001. This should be putting data in now. Oh no, that just sets register selector the other way, that's right. And then 4102, that should put something on the display. Oh, it has, but the contrast has gone all weird. Let's do the final 3 steps. Yeah, that's worked, but I don't know why the contrast is weird. Let me just find a screwdriver and try and twiddle the pot. I can see it, but it's just not showing up very well. Where is the pot on here? There it is. Let's try adjusting the contrast. Oh yeah, there it is. I'll get the contrast so it looks black on white. It isn't, it's actually the other way around, but it's just the angle it's looking at. So that has worked. That program sets the display up. It doesn't put the cursor back at the beginning. There's another command for that. We could do that. But then it writes A and B to the display. And it's worked. So I should, in theory, be able to write a hello world. And I could probably write it such that it writes the letters visibly slowly and then loops back, clears the display. So I'll add the clear display command into this set and then writes hello world again. So it just continually writes it, clears the display and writes it again. It's going to be a long program, but I think it's worth keying that in back when I've done it. In fact, just before I do that, I've got this looping round doing my AB program, and you can see that although every time it loops around it goes back into command mode and sets this to flashing cursor, that doesn't lose the cursor position. Got some funny contrast effects happening when it's in command mode, but it's continuously writing AB to the display very slowly, but then it takes a lot of instructions to actually get all this data across. So yeah, this is gradually filling up. I can't remember whether 38 sets it to 1 line or 2 line. We'll see what happens when this gets to the end of that line. But yeah, when that's a 0, it's writing commands, and the display fades out slightly for some reason. When this says 01, it's writing data. So when this says 01, you'll see the A and the B appear. Let's just see what happens when that gets to the end of the line. Will it go into lines 3 and 4? Yes, it has. How interesting. Just not quite sure what this contrast effect is when it goes into command mode, but it seems to be quite nicely contrasted in display mode. Yeah, interesting. So it should be possible to get hello world to work. Probably have to speed this up. In fact, let's speed it up now, and then the A and B should be a bit quicker. Yeah, that's actually running a program. It's about the first time that's ever happened. So it's quite exciting, really. Yes, I must write the hello world because that's going to be the intro to this. Right, I've written a program which sets the RS line low, then does the necessary setup for blinking cursor, then does a clear display, then sets the RS line high for character data, and then writes hello. And then I wimped out because I just couldn't be bothered to go on to world. So I'm going to key this in and just make sure this works, and that the clear display removes everything and then it writes it all over again. That takes me up to 11101, whatever that is in decimal. So let's turn the power on. Yes, it normally boots up with this bizarre A5 and 5A thing so that it runs a 2-step sequence. But I can clear that and start entering this. Would you like to see a bit of the process? So 3 goes to 4. Obviously. Oh, we got some dodgy connections. How is my power distribution holding out? Obviously not brilliantly. So 3 goes to 4, and on step 3 it's 00. Oh, it's all flickering a bit. Never mind, let's plow on. Next, 4 goes to 5, quite obviously. and in step 4 we've got O1. So I'm programming the go-tos and the data together. Sometimes I go through and do all the go-tos and then go back and do all the data for each location. But I just thought I'd do it this way this time. 100 is 4. That goes to 5. We've done that, haven't we? Yeah. 4 is oh, why have I got that? 100 should be FO. I need to check this. Let's check it again. 0 goes to 1 and the data is 0. 1 data is 0. 2 data is... You see, I think actually it'd be easier to go through programming all the go-tos and then come back and program all the data. I think it'd just be easier that way. I'm going to do that. This display has got so bad I can't even see what I'm doing now. So I think, because I plugged this in here, that was silly, I'll cut a new piece of red and black wire and poke them in these holes here so that my battery power, assuming my batteries are good, goes straight into the middle of the board. I'm going to do that. So I'm actually going to power off, lose what I've done, come back and start again. Right, let's try that. Switch on. Oh, that's brighter. Oh, got funny numbers on here. Got C8 on there, but then that's because everything's needs to be reset. So 0 will take 1 and so on. So let's program in all my go-tos first and then I'll program in all my instructions. So I've programmed in a 5-bit counting sequence. I think it's all in there. Yeah, it appears to be. And then on 11111 I've told it to go back to 0. I will overwrite that because I don't quite go that high. I go to 11101, but I just thought I'd put in a full sequence and you can see that it's all in there. Good. Okay, so now in each location I'll stop the clock and I'll reset it back to address 0. I'll put in all the data for each address and we'll see if it works. I'll just show you the last bit of programming. Can't really see this at the same time. I'll try and do that. 10111, I think I've done 02. Yeah, that's 02. So move on. 11000. 11000, 60. This is a bit in my way actually. 60. Move on. 11001. 11001 C0. What's C? It's that C0. Move on. 11010 02, which is that. Move on. 11011 60, which is that. 11100. 11100 is F0, which is that. And finally 11101 is 02. Bring those down. 02. Now I need to loop back, so probably the next instruction, well no, this instruction now needs to jump back to address 0. Address 0 is in there, so I program that in. That will do the jump back to 0. And that should be it. I'll leave the camera running because this is the exciting bit. Let's see if it works. Let's free run it. Oh, flashing cursor. Oh, look at that. Hello. Now it should, yes, it clears the display and writes hello again. Clears the display and writes hello again. Right, time to speed it up. Which is the speed up direction? No, that's the slow down. Don't want to go too fast because I don't want it to make mistakes. But yeah, I'll bring the camera down so you get a better idea of what it's doing. Okay, so I didn't go to Hello World because I was too scared. But I've gone to Hello. And then it does a clear display and writes it again. I think that's a result. Right, I'm just going to do my intro now. So there we are. It's not quite hello world. I could do hello world, but it's exhausting writing this code. This thing really does live up to its name of Oink because it is a pig to program. This is the program. It's quite long because you have to create all the literals individually in 2 nibbles and then write them to the LCD. And that's the result. And I'm pretty happy with that. So I think I'll leave it there. Cheerio.